Welcome. Awer, Indo, Dumilang, Molo, Saubona, Hugandet, and a warm welcome to the Induho Knowledge Cast, the podcast where your curiosity meets insightful conversations. Today, we're diving into the fascinating world of statistics, a field that's way more connected to our daily lives here in South Africa than you might think. We're bombarded with stats all the time, in the news, economic forecasts, even those health studies we see. But how do we know what to trust? And what's the story behind those numbers? That's where our expert comes in, ready to guide us through these excerpts you've shared from Statistics. A very short introduction by David J. Hand. So let's jump right in. The book starts by challenging the idea that statistics is just about manipulating numbers, saying it's actually exciting.
It is exciting. It's like detective work, really.
He actually compares it to detective work.
Yeah, using numbers to uncover hidden truths, to see those patterns that aren't obvious at first glance.
It's about the story behind the numbers, not just the numbers themselves.
Exactly. And just like a detective needs to be careful not to misinterpret clues, we need to be careful with how we interpret statistics.
It reminds me of that tragic case mentioned in the book, the Sally Clark case. 2 caught deaths in one family, statistically very rare, which led to a flawed expert testimony. Really highlights how misunderstanding the context behind those numbers can have devastating real-life consequences. And speaking of context, the book talks about bad data, incomplete or inaccurate information, something we probably encounter more than we realize, right?
Oh, absolutely. Think about the Challenger space shuttle disaster.
Right.
Incomplete data about those rocket booster seals led to that tragic launch decision.
And here in South Africa, with our history of inequality, bad data could mean missing voices, skewed demographics. Makes you think twice about those surveys and reports, doesn't it?
It definitely does. Hand, the author, suggests really focusing on data quality from the get-go,
So it's not just about collecting more data.
No. Clear definitions, understanding potential biases, and being aware of how even small errors can snowball.
It's like what's that thing, a house of cards.
Yeah, exactly. One weak card and the whole thing collapses.
So it's not enough to just have lots of data. It has to be good data. But how do you even define good when you're dealing with something as complex as, say, crime rates, which the book also talks about?
Yeah, that's the thing, isn't it? Even something we think is straightforward, like defining a crime, it's got layers.
Right, because a crime in one context might not be a crime in another.
Exactly. What acts are classified as crimes? How is it reported and recorded? And these definitions can change over time. They can change across different areas.
So trying to compare crime stats from different provinces, are we even talking about the same thing?
Precisely.
It's a good reminder that even seemingly objective data, like crime statistics, can involve a lot of subjective judgment.
Absolutely. And then when you've got these massive data sets, often compiled by multiple people, you've got the chance of just human error multiplying.
Oh, for sure.
The book actually mentions a census in the U.S. where they somehow ended up with a bunch of 14-year-old widows.
14-year-old widows. That's statistically.
Clearly an error, but it slipped through.
Wow. Okay, that's a bit terrifying, actually. So how do you even begin to clean up, I don't know, what would you call it, dirty data?
Yeah, dirty data, that's a good way to put it. Well, there are techniques, of course. Sometimes it's about making an educated guess to correct for, obvious errors.
Right.
But with huge data sets, you need automatic outlier detection methods.
So using algorithms and things.
Exactly, but they're not foolproof either.
Right.
It's a constant battle to improve data quality as the volume of data just keeps growing and growing.
And now with computers handling so much of this data, I imagine that even opens up new avenues for error, new types of errors that can crop up.
Absolutely. A tiny typo can have massive consequences.
Like that movie, what was it, Office Space?
The book mentions a case in the U.S. where a house was accidentally valued at $400 million instead of its actual value.
400 million.
400 million, which was more than 1,000 times less than that.
Oh, wow.
This mistake messed up tax calculations, caused budget problems. They were risking jobs.
From one little typo.
It just shows how a single data point, even a really obvious error, can have this huge ripple effect.
The cautionary tale for our digital age. So it seems like being aware of potential data issues, that's the first step. What else can we do, especially as individuals kind of encountering statistics daily?
Asking critical questions is key.
Like what? Give us an example.
What's the source of this data? How was it collected? Are there any potential biases or errors? Could the data be incomplete?
Right, so not just taking things at face value.
Exactly. Developing that healthy skepticism towards statistics, it's so important.
So the next time I see a headline about a new study or a poll, I should be thinking, okay, but what's the story behind these numbers?
Yes. Don't just accept the numbers at face value. Dig a little deeper, and you might be surprised by what you find.
That makes a lot of sense. Now, the book also talks about understanding how data is collected, specifically the difference between observational and experimental studies. What's the key difference, and why should we care?
You've hit on a really important point. Observational studies are kind of like watching the world unfold without interfering. Imagine you're studying the relationship between height and weight.
Okay.
You observe, you measure, you don't intervene.
Okay, so you're not manipulating anything, you're just observing.
Exactly. Experimental studies, on the other hand, involve deliberately changing something to see what happens.
Okay,
Think of a clinical trial. Some people get a new drug, others get a placebo.
got it.
You're actively intervening to see if that drug makes a difference.
So if I wanted to know if, say, a new teaching method improves reading skills, an experimental study would be more reliable than just observing classrooms.
Precisely. Because with just observations, other factors could be at play that you haven't accounted for.
Like maybe the kids who are already good readers were put in a specific class, so it makes that method look better than it is.
Exactly. That's why in an experiment, you'd randomly assign students to different methods. That helps to even the playing field.
Makes sense. Now, thinking about all the research done here in South Africa, especially on social and economic issues, I imagine both types of studies are used, depending on the question.
Absolutely. If you want to see the effects of a new social policy, you might do a randomized controlled trial, assigning communities randomly to receive the policy or not.
Right, right.
But to understand the current state of poverty, you'd likely rely on observational data, like surveys and census information.
So the type of study design, it really matters. It depends on what you're trying to uncover.
Absolutely. It's about choosing the right tool for the job. The book highlights two key disciplines for collecting good data: experimental design and survey sampling.
Okay, let's break those down.
Let's start with experimental design. Now, this isn't as straightforward as it might sound. It's about setting up experiments strategically to extract maximum information.
So it's more than just mixing things up in a lab and seeing what happens.
Way more. You want to maximize your findings. Right. That means things like figuring out the right sample size,
Okay.
controlling for other variables that could skew your results,
Right.
and using randomization to minimize bias. Think of testing different combinations of, say, water and fertilizer on crops.
Okay.
A well-designed experiment would test various levels of each in different combinations, right? This shows not just their individual effects, but how they interact.
That makes a lot of sense because in the real world, it's rarely just one thing influencing another. It's usually a complex web of factors.
Exactly. And a good experimental design helps you untangle that web.
Okay. I'm starting to see how much thought goes into this.
Mhm.
Now, what about survey sampling? That one's always kind of puzzled me. How can surveying a small group of people give you reliable insights into an entire population?
Ah, the magic of randomness.
Okay, go on.
Think of it like stirring a pot of soup. You only need a spoonful to get a good sense of the overall flavor, right?
Okay, I like that.
If you randomly select your sample from the population, it's going to be surprisingly representative of the whole.
Okay, that's a delicious analogy. But I imagine true randomness is trickier to achieve than just stirring a pot of soup.
You're absolutely right. In reality, it's really tough to get perfect randomness. The book mentions this case, a U.S. presidential election poll that got it completely wrong because they only surveyed people with telephones and cars.
Oh, wow.
Now, back then, those were signs of wealth, so their sample didn't represent the average voter at all.
It's a good reminder that even when you're trying to be random, biases can still sneak in.
Absolutely. That's why statisticians have developed methods to try and minimize that bias. There's stratified sampling, where you divide the population into groups and then randomly sample within each group.
So like making sure you have representation from different provinces, races, income levels here in South Africa.
Exactly. You want to make sure you're capturing that full spectrum of views within the population.
Makes sense.
And then you also have to consider those who don't respond to your survey.
Oh, right.
The people who do respond, they might not be a good representation of everyone. So statisticians use techniques like reweighting the data to account for those underrepresented groups.
Wow, so much goes into creating a reliable survey. It's definitely a lot more than just sending out a questionnaire and tallying up the responses.
You got it. It's a complex process, but when it's done right, incredibly powerful for understanding things like public opinion, social trends.
It really highlights that this data collection, whether through experiments or surveys, is the foundation for all the statistical analysis that follows.
If your data is flawed from the start,
Your conclusions will be too.
exactly, garbage in, garbage out, as they say.
It strikes me that even with the best data collection methods, we're still dealing with uncertainty, right?
Right.
And that's where I guess this idea of probability comes in. It's like the language of chance, which the book delves into quite a bit.
Exactly. The future is inherently unpredictable,
That's for sure.
and probability gives us a way to kind of wrap our heads around that uncertainty, to quantify it.
So instead of just throwing our hands up and saying anything could happen,
Sure.
we can actually use probability to get a handle on just how likely those anythings are.
Precisely. It assigns numbers between 0 and 1 to events, representing how likely they are to occur.
Okay, so a probability of 1 means something's definitely going to happen.
It's certain. Like the sun rising tomorrow, a probability of 0 means it's impossible.
Like me winning the lottery if I don't buy a ticket.
Exactly. And everything in between, that's a measure of how much uncertainty we're really dealing with.
So even when we can't predict the future for sure, probability gives us this framework for making more informed choices. Like, I don't know, when you decide to drive a car, you know there's a risk of an accident, but the probability is hopefully low enough that you feel okay taking that risk.
That's a great way to put it. It's about weighing the likelihood of different outcomes and making decisions based on those probabilities.
Now, the book mentions these different interpretations of probability, like the frequentist view, for example. What's that all about?
So imagine flipping a fair coin.
Okay.
The frequentist view, it sees probability as that long-term proportion of times an event happens if you could repeat the experiment over and over again.
Okay, so like if I flip this coin enough times,
Flip that coin 1,000,000 times, the proportion of heads, it should get closer and closer to 0.5. That's the frequentist probability of getting heads.
so it's based on what happens over many, many trials.
Exactly. But, of course, in real life, we can't flip a coin an infinite number of times.
Right, we don't have time for that.
So we have to estimate that probability based on a limited number of observations.
Which makes sense. Now, what about that other interpretation, the subjective view? How's that different?
So this one sees probability more as a measure of personal belief, how confident you are in something happening. Think about like a seasoned investor.
Okay.
They might have a very strong subjective probability about whether a particular stock will go up or down based on their experience, their knowledge.
So it's more about intuition, judgment based on what you know.
Exactly. And both interpretations have their place. The book gives the example of trying to predict the next U.S. presidential election.
Okay.
The frequentist view, not that helpful because you can't repeat the same election an infinite number of times.
Right. Each election is unique.
Exactly. But someone with a deep understanding of politics, they might have a very strong subjective probability based on their analysis.
So again, it's about using the right tool for the job.
Absolutely.
Different approaches to probability can be useful depending on what you're looking at. Now, the book also talks about what is it called? The laws of chance.
Yes.
What are those and why are they so important?
The laws of chance, they're like the rules of the road for probability.
Okay.
They govern how probabilities work, how they interact. One key law is this concept of independence. Two events are independent if the outcome of one doesn't affect the outcome of the other, like flipping a coin twice.
So the first flip doesn't influence the second.
Exactly.
So even if I flip heads like 10 times in a row,
Yeah,
the probability of getting heads on that 11th flip is still 50-50.
you got it. But not all events are independent.
Right, of course.
The book gives the example of slipping on the street. That probability is definitely affected by whether or not it's snowing.
Very true. If it's icy out there, my chances of taking a tumble, they skyrocket.
Exactly. And when events aren't independent, things get a bit more complex. We can't just multiply the individual probabilities together to get the probability of both of them happening.
Right.
This actually reminds me of that tragic Sally Clark case again, where the expert witness made a mistake, assuming the probability of 2 cot deaths was just the product of the individual probabilities.
So they didn't account for the fact that there might be other factors at play making those events not independent.
Exactly, which is a huge oversimplification.
Right. So understanding how probabilities work together or don't work together is crucial for making these accurate assessments.
Absolutely. It helps us avoid making those faulty assumptions, which, as we've seen, can have real-life consequences.
Now, the book also dives into this concept of a random variable, which sounds a little intimidating.
It's not as scary as it sounds.
Okay, good.
Think of it like this. A random variable is something you measure where the value depends on chance.
Okay.
It's like the number of heads you get when you flip a coin 10 times. That number could be anything from 0 to 10, depending on how those coin flips turn out.
So it's a variable because the value can change, but it's random because that value is determined by chance.
Exactly. And each random variable, it comes with what's called a probability distribution, which basically tells you the likelihood of getting each possible value.
So for my coin flip example, the probability distribution would tell me how likely I am to get 0 heads, 1 head, 2 heads, and so on, all the way up to 10 heads.
Precisely. The book mentions several important probability distributions. There's the Bernoulli distribution, which is like a single coin flip.
Okay.
The binomial distribution, that's like multiple coin flips. The Poisson distribution, often used for rare events, like the number of accidents at an intersection on a given day. And then there's the most famous one, the normal distribution.
Ah, yes, the bell curve. I remember that one from, I think it was my stats class back in the day.
It's a classic. Many things in nature actually follow this bell-shaped curve.
Really?
Heights and weights, IQ scores, blood pressure readings.
Wow. I had no idea it was so common.
It pops up everywhere.
So it seems like these probability distributions, they're essential for understanding how random variables behave.
They give us a framework for making predictions, testing hypotheses. For example, if you're a retailer and you want to predict the demand for a new product, you could model that demand as a random variable.
Okay.
And by understanding its probability distribution, you can make better decisions about your inventory, about pricing.
So if I could figure out the probability distribution of how many avocados people buy each week, I can stock my store accordingly and avoid those sad, overripe avocados.
Exactly. You're using probability to your advantage to run your business more efficiently.
Amazing. So we've gone from understanding how data is collected to using probability to make sense of uncertainty. The book then takes us into statistical inference, which I guess seems like the next logical step.
It is. Statistical inference is all about taking what we've learned about probability and using it to draw conclusions from data, especially when we only have a sample and not the entire population.
Okay, that makes sense. So if I run a survey here in South Africa and I find that, say, 60% of my sample supports a particular policy, can I just assume then that 60% of the entire country feels the same way?
Not so fast. You're working with a sample, not everyone, so there's always a chance for error. But that's where statistical inference comes in.
Okay.
It gives us the tools to quantify that uncertainty and make probabilistic statements about the whole population.
So it's like saying, based on this sample, we're pretty confident that the true level of support is somewhere between 55% and 65%, but we can't be 100% certain.
Exactly. It's about acknowledging that uncertainty that's inherent in working with samples and using statistical methods to make the most informed inference. The book mentions different methods of statistical inference, like estimation, where you use your sample to estimate population parameters.
So things like the average height, the average income.
Exactly.
So if I wanted to know the average height of women in South Africa, I'd measure the height of the women in my sample and use that as my best guess for the whole population.
That's the general idea. Of course, statisticians have more sophisticated methods than just using a simple average, but the principle is the same. You're using your sample to make an educated guess about that whole population.
Okay, that makes sense. Now, what about hypothesis testing? That's another one of those terms I vaguely remember from stats class, but could use a refresher on.
Hypothesis testing is where we get to play detective with data.
Oh, I like that.
It's about using our sample to test a specific claim about that population. Like, is this new drug actually more effective than the existing one? Or is there a difference in average exam scores between students who use different study methods?
So it's about going beyond just describing the data and actually trying to see if there's evidence for a particular idea.
You got it. You start with a hypothesis, maybe that there's no difference between the groups you're comparing, and then you see if your data provides enough evidence to reject that hypothesis.
So in that drug example, if my data shows a big enough difference in outcomes between the group that got the new drug and the group that didn't, I might have enough evidence to say, hey, it looks like this new drug really is more effective.
Exactly. And the book explains that this approach, it helps us make more rigorous and objective decisions based on data, rather than just relying on intuition or anecdotal evidence.
It's like having this systematic way to actually evaluate the evidence and then make more informed choices.
Exactly, taking some of that guesswork out of it.
Now, the book also mentions Bayesian inference as another approach to statistical inference. This one's interesting because it allows us to bring in prior knowledge into our analysis, right?
Exactly.
So instead of just looking at the data in isolation, we can actually incorporate what we already know or what we believe to be true.
It's like starting with an educated guess and then refining that guess based on the data. For example, if you're studying the prevalence of HIV in South Africa, you might have some prior knowledge from previous studies. Bayesian inference allows you to combine that prior knowledge with this new data to hopefully get a more accurate picture.
That seems incredibly useful, especially in fields where we have, a lot of existing knowledge to draw on.
Absolutely. Bayesian inference is actually becoming increasingly popular in many fields: medicine, finance, even artificial intelligence. It allows us to make more nuanced and informed decisions by combining that data with what the experts already know.
It's like the best of both worlds.
Exactly.
This is all fascinating stuff, but I have to admit, I'm starting to feel the limitations of my old stats textbook.
Yeah.
It sounds like the world of statistics has come a long way.
It really has. The book emphasizes this role of statistical computing in modern statistics. With powerful computers, we can now analyze these massive data sets, build complex models that were just unthinkable before.
So it's not just about knowing those formulas anymore. It's about knowing how to use computers to do the heavy lifting.
Exactly. It's opened up all sorts of new possibilities for analysis, allowed us to tackle these problems that were previously just intractable.
That makes sense.
Mm-hmm.
But even with all this computing power, we still need to be able to understand and interpret those results, right? And that's where data visualization comes in, right? Turning those numbers into something we can actually wrap our heads around.
Data visualization is like that bridge between, complex statistical analysis and human understanding. We can use computers to generate these graphs, charts, maps that help us see the patterns and trends in data that might otherwise go unnoticed.
It's like that saying, a picture is worth 1,000 words. But in this case, a picture is worth 1,000 data points.
Exactly. A well-designed visualization can communicate complex information so much more effectively than, any table or equation ever could.
For sure.
The book really stresses the importance of clear, concise visuals that avoid clutter, that avoid distortion. You really want to make sure that the story the data is telling is easy to grasp.
So it's not just about making pretty pictures. It's about using those pictures to actually communicate those insights effectively.
Exactly. And ultimately, that's what statistics is all about, right? Using data to gain insights and to make better decisions.
This deep dive into statistics has been really eye-opening. It's amazing how much goes on behind the scenes of those numbers we encounter every day.
It's definitely more than meets the eye. The book does a great job of showing that statistics isn't just about, crunching numbers. It's a way of thinking, a way of understanding the world around us.
And a key part of that, it seems, is the use of these statistical models, right? What exactly is a statistical model, and why are they so important?
Imagine trying to understand something incredibly complex, like the South African economy.
Okay, yeah.
There are so many factors involved, so many moving parts. A statistical model is like a simplified representation of that complex system, focusing on those key variables and how they relate to each other.
So it's like a map that helps us navigate this complex landscape.
Exactly. It helps us see the forest for the trees, helps us identify the most important factors and how they all interact.
Now, the book talks about these different types of models. Can you give us a quick rundown of some of the main ones?
Sure, there are descriptive models, which basically help us summarize and understand what's happening in the data.
Okay.
Think of it like a snapshot of the current state of things.
Okay.
And then you've got predictive models, which try to forecast what might happen in the future, like those economic growth predictions we talked about earlier.
Right. So a descriptive model might show me the current income distribution in South Africa, whereas a predictive model might try to forecast how that distribution might change in the next 5 years.
Exactly. And the type of model you use depends on the questions you're asking.
Makes sense. The book also mentions this danger of overfitting a model. What does that mean, and how do you avoid it?
Imagine you're trying to draw a line through a bunch of data points.
Okay.
You could draw this really, really complex line that twists and turns to hit every single point perfectly. Okay?
That's overfitting. The model is so focused on that specific data you gave it that it doesn't generalize well to new data.
So it's like memorizing the answers to a test. instead of actually understanding the concepts.
Exactly. And just like that student who memorizes answers isn't going to do well on a new exam, that overfit model won't be very useful for making predictions about new situations.
So how do you make sure that your model is actually learning something useful, not just memorizing the data?
Well, one technique is called cross-validation. You basically split your data into two parts.
Okay.
You use the first part to train the model, and then you use that second part, which the model's never seen before, to test how well it generalizes.
Ah, so it's like a test run to make sure the model can handle this new information it hasn't seen before.
Precisely. Cross-validation helps you strike that balance between complexity and generalizability.
Right.
You want a model that's sophisticated enough to capture those important patterns in the data, but not so complex that it just overfits.
Right. Finding that sweet spot.
Exactly. Now, the book covers a lot of ground when it comes to different statistical methods. Could you walk us through some of the key ones just to give our listeners a taste?
Sure. Regression analysis is a big one.
Okay.
It's all about understanding the relationships between different variables. Like, how does level of education relate to income? Or how does rainfall affect crop yields?
So if I wanted to predict someone's salary based on, say, their years of experience and their level of education, I could use regression analysis.
Exactly. And there are different flavors of regression,
Okay.
like linear regression, which assumes this straight line relationship between those variables.
Okay.
And then there's logistic regression, which you use when that outcome you're predicting is binary, like yes, no, or present absent.
Got it, got it. The book also mentions ANOVA, analysis of variance. What's that all about?
ANO is a way of comparing different groups to see if there are any statistically significant differences between them. Like, do students who receive a new teaching method perform differently on a test compared to those who receive a more traditional method?
So it helps us figure out if a particular intervention or treatment is actually having an effect.
Exactly. It's often used in clinical trials and other experimental settings to see if that new treatment is really making a difference.
Fascinating stuff. Now, what about these classification methods? What are those used for?
Think about those spam filters that keep all those unwanted emails out of your inbox.
Oh, yes. Thank goodness for those.
That's classification in action. It's about taking a set of data and assigning each item to a particular category.
So if I'm a bank trying to detect fraudulent transactions, I could use a classification algorithm to kind of flag that suspicious activity.
Exactly. Or a doctor might use a classification algorithm to help diagnose a patient based on their symptoms. And there are different types of classification as well,
Okay.
like supervised learning, where you train the algorithm on labeled data, and unsupervised learning, where that algorithm actually tries to identify those natural groupings in the data without any predefined labels.
It's like the algorithm is learning on its own.
In a way, yes.
This is all incredibly powerful stuff. It's amazing to see how these statistical methods are being used in so many different fields.
It truly is. And we've only just scratched the surface. The book also touches on things like multivariate analysis, which is essential for dealing with these data sets that have just tons of different variables. It's like trying to untangle a really, really complicated knot. You need specialized tools to make sense of it all.
This deep dive has been incredible. It's clear that statistics is this vast and rapidly evolving field. But if there's one key takeaway for our listeners, what would it be?
I think the most important message is that statistics is for everyone, not just for mathematicians and scientists.
I like that.
It's a way of thinking critically about information, of understanding uncertainty, and of making better decisions in a world that is just absolutely awash with data.
Beautifully said. So listeners, the next time you see a statistic, don't just take it at face value. Ask questions, dig deeper. Remember the tools and concepts we've discussed today. Who knows? You might even discover a hidden passion for statistics. That's all the time we have for today's deep dive into the fascinating world of statistics. A huge thank you to our expert for guiding us through this complex and important topic. And to our listeners, as always, thank you for joining us. Until next time, keep those minds curious.